Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter number systems. Now let's go for continuing this. And this is 7th period of this chapter. Dear students, in the last class we focused on how to represent some of the numbers on the number line, right? It may be the rational number, that is in P by Q form. It may be the irrational numbers like root 2, root 3, root 5 and so on. And some decimals also, particularly square root of decimal numbers on the number line. And representing the decimal numbers like terminating or non-terminating recurring up to some decimals, right? These were represented on the number line, and all these are very important in the examination point of view. I hope that you all have practiced these. Now today we are going to focus on another important concept in the examination point of view. It is operations on real numbers. We are very familiar with the fundamental operations. What are those? Addition, subtraction, multiplication and division. And we have applied all these up to rationals. But have you ever solved the problems, particularly operations on irrational numbers? May not be. So now let's go for learning that. Before that, just observe here. What do you call the counting numbers? They are all natural numbers, including 0, whole numbers with their negatives, integers, which can be expressed in the form of P by Q, rationals, which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. They are irrationals. Observe here, these are one group of numbers and these are another group of numbers. Observe these two groups carefully. I hope that you can understand. It is a spect which includes two lenses. In that, all types of numbers are there. And all these numbers together called real numbers. Clear? A collection of rationals and irrationals are called real numbers. Today, we are going to focus on operations on real numbers. To understand that, it is better to know about one of the important concepts. Now I am going to introduce that. Observe it. Here I will write some of the numbers like 2, 3, 5, then 2 by 7. What are these? These are all rational or irrational? Yes, rational numbers. Now you just go for observing these. What is the value of root 2? Is it possible to take this rational number from the root? No. 3 from the root side? No. Then cube root of 5. Square root of 2 by 7. Fourth root of 9. Alright. 11 into fourth root of 9. See, these are the rational numbers 2, 3, 5, 2 by 7 and 9, which cannot be taken out from the root. Hence you can call these roots as irrational roots. The irrational roots of rational numbers is called assert. It may be new word for you, but it is inevitable to know about it. The irrational roots of rational numbers is called assert. Then it has some of general form. Let me go for writing that. Okay. The irrational roots of rational numbers is called assert. Then it is much important to learn the operations on real numbers, particularly irrational numbers. The general form of surd is, it is x into nth root of a. Then you all may be thinking that, then what are these terms? Where x is called coefficient, n is called order, then this symbol, it is root, and one more a, it is called radicand. Radicand. Clear? If I take some of the examples for surds, nothing but irrational numbers. Here I'll write cube root of 7, 11 into square root of 2, 13 into fourth root of 5. These are some examples for surds. Observe here. In first example, can you tell what is the coefficient? If nothing is there, it is understood. 1. Then what do you call 3? It is order. 7, radicand. Here 11, coefficient. Here, what is the order? Here nothing is there inside this V shape. It is 2. Order is 2. Radicand is 2. Coefficient is 13. Order is 4. Radicand is 5. Got it? Now let us discuss about operations on these irrational numbers. Let me go for writing that. Dear students, now I am going to write two groups of surds. You just keep observing, and also you have to identify the order and radicand. And based on that, we can go for a conclusion. Let me go for grouping them. As I said, two groups will be made. I am going to write them separately in two different columns. Observe, in the first group, first column, first group, it is square root of 2. This is 2 into square root of 5, 3 into square root of again 5. Got it? Next, here I'll take this as 5. It will be easier to understand. Next, another one, square root of 2, 3 into square root of 2, 11 into square root of 2. I take one more group. It is cube root of 11, 7 into cube root of 11, 5 into cube root of 11. Clear? This is, here I have written three groups of surds. Now observe in the second column. Again I am going to write few more. Here 2 into square root of 5, 3 into square root of 11. Then another group. 5 into cube root of 2, 3 into cube root of 5. And one more. It is square root of 2, cube root of 3, fourth root of 5, and so on. When you observe these groups of surds, in the first group, you can come to know in each example. Here I told you in the beginning, you have to observe the order and radicand. In these, what is the order? 2. What about the radicand? 5. Order 2. Radicand 2. Order here 3. Radicand 11. Right? A surd in which a group of surds having same order and same radicand, they are called like surds. Like surds. Then here you can observe that. What is the order? 2. Here 2. Order may be same. But what about the radicand? 5 and 11. They are different. Here radicands are same, order are same, radicands are different. Here order 2, 3, 4 different, radicands 2, 3, 5 they are also different. Got it? So such surds are called unlike surds. Got it? A surds in which a group of surds having different order and different radicands are called unlike surds. I think you all may be thinking that what is the necessary for knowing like surds and unlike surds? Dear students, as we have the heading that operations on real numbers. So far we have got operations on up to rational numbers. One more type is the irrational. That is why we need. And if like surds are there, they can be, here I am writing, they can be added. You can go for using fundamental operation, that is plus. You can go for subtracting them. You can go for even multiplying as well as division. Clear up? Whereas unlike surds are there, you cannot add them. You cannot subtract also. You can go for multiplying or division with some condition. Multiplication can be employed or division can be employed with condition. Got it? You have to remember this one. So here I'll write like surds and unlike surds. Now I'm going to complete it. Let's complete the table. This is very important to know. This particular heading is not given in your textbook, but it is much needed to understand the further problems. Okay, now we will move on to solving the problems. I'll go for teaching and please go for copying from here to there. Yes. Dear students, before going to operations on real numbers, again we need to know few more things. And one more information I'll give you. It is better to have the good knowledge about squares of the numbers from 1 to 25. That is 1 square is 1, 2 square is 4, 3 square is 9, 10 square is 100. Got it? Like that. 15 square is 225, 21 square is 441, 24 square is 576 and 25 square 625. Like this. Even cubes of the numbers from 1 to 10. 1 square is 1. 2 square is 8, that is 2 into 2, sorry, 1 cube is 1, 2 cube is 8, 2 into 2 into 2, 8, 10 cube is 1000, 10 into 10 into 10, okay, please learn this. After that, then you have to observe this one. Look here, express the following in simplest form. Is wrong, irrationals, but we have to express them in simplest form. How? Let us come to know one by one. The very first one is square root of 18. The square root of 18 can be written as the product of its factors. We can write it as 9 into 2. Right? Why should we go for taking 9 into 2 only? Because 9 here, one of the factor is perfect square. It will be easy to take out. Then square root of 9 into 2 can be written as square root of 9 into square root of 2. Then what is square root of 9? It is 3. Right? In 8th standard only you have learnt about squares and square roots, cubes and cube roots. You can just recall that. So 3 into root, because 2 cannot be taken from the root. Clear? Yes. Let's go for second one. Square root of 48 is there. Then how do you write this? Will you go for taking 24 to the? Of course you can. But in that factor, one should be perfect square. The reason is here order is 2. If you, what is that perfect square? You should recall the table of perfect square. See that here it can be written as 16 threes are 48. Square root of 16 into square root of 3. What is square root of 16? 4 into root 3 as it is. Understood? Are these simple? 100% they are simple. And this will help us to learn the further problems. So you need to practice it. Next, square root of 150. Then which perfect square would you like to assume? Whether you go for 100, will not come. Whether you go for 50, it comes 53, sir. But 50, whether it is perfect square? No. Hence, I go for taking square root of 150 as square root of 25. How much, sir? You are familiar with the table 25. 25 6 are 150. Then what is square root of 25? 5. Square root of 6 as it is. Here also order 2 is there. Then how do you simplify square root of 32? Yes. Square root of 32 can be written as 16 into 2. It's equal to square root of 16 is 4 into root. Next, fifth one. Observe the order. Here 3 is there. So you need to have the knowledge about cube numbers. You are going to express 16 as the product of two factors. In these two factors, one should be perfect cube. How do you go for taking cube root of 16? Yes, cube root of 16 can be written as 8 into 2, right? Because 8 is a perfect square. That is 2 into 2 into 2. This is equal to, for the sake of understanding, I go for writing 8 as 2 cube, right? Into 2. It is equal to cube root of 2 cube into cube root of 2. Now see that cube and cube root get cancelled. How much will remain? 2 will remain and cube root of 2 as it is. Next, I have taken one more. See the cube root of 54. Then which perfect cube is going to be taken? Yes, you are right. It is 27. 27 2s are 54. 27 is a perfect cube. How? 3 into 3 into 3. 3 3s are 9. 9 3s are 27. Hence we can write cube root of 3 cube into 2. It is cube root of 3 cube into cube root of 2. Cube and root. Cube root get cancelled. 3 into cube root of 2. Next. Here fourth root of 32 is there. Now, you can go for solving like this. Fourth root of 32. It is equal to fourth order is 4 is there. Hence, can we go for writing 32 as 16 into 2? Yes or no? If you tell yes, how? Just think over it. Here 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 can be expressed as 2 raised to the power 4. Fourth root of 2 raised to the power 4 into 2. Fourth root of 2 raised to the power 4 into fourth root of this 2. 4 power 4 and fourth root get cancelled. You will get 2 into fourth root of 2. Clear? Next, one more example. Again, fourth root of 162 by trial and error method. Which one you will go for? 2 cube, 2 raised to the power 4. Will you go for taking 16? Won't come. Then you have to take 3. 3 3s are 9. 9 3s are 27. 27 3s are 81. 3 raised to the power 4. 81. 81 2s are 162. So it comes fourth root of 81 into 2. Then fourth root of 81 into fourth root of 2. Fourth root of 81 is, directly you can write 3. or 3 raised to the power 4. Power and 4th root get cancelled. 3 into 4th root of 2. This is the way you have to solve. Clear? So without fail you have to practice. See that all these are very important in the to learn the further problems effectively, correctly. Okay. Please go for copying all these 8 problems from there to here. Pause the video and write. Dear students, now we are moving to actual problems. That is operations on real numbers, particularly irrational numbers. Here we are going to simplify some of the problems, some of the irrational numbers with respect to only addition and subtraction. Here most of the problems are in addition part only. Observe. I have already told you all these are sets, and like sets can be added or subtracted. Look here. What are like sets? Just to recall, order should be same and radicand should be same. In the first one, what do you say? Are they like? Yes. You have to like 3 root 2 plus 5 root 2. Both are like sets. Only coefficients are different. So under such condition, you can go for writing like this. 3 root 2 plus 5 root 2 as is, which is equal to root 2 is there. You can take out root 2 as common factor. 3 plus 5 will remain. What is 3 plus 5? 8. 8 root. This is the answer. Understood? Now come to this one. Here also just I have taken the root numbers. Just square root. 8 root 3 minus 2 root 3 plus 4 root 3. Are they like or unlike? Yes, they are also like sets. Then same order 2, same radicand 3. Hence I can go for taking root 3 as common factor. Then remaining 8 minus 2 plus 4. What is 8 minus 2? 6. 6 plus 4? 10. 10 root 3. Next, observe here. These are bit somewhat different, right? Look here. Square root of 48, square root of 72, square root of 27 and square root of 18. Are they? Do you say that? Are they like? No. So if you want to decide whether they are like or unlike, you have to express them in the simplest form. Just we have learned in the first problem. I go for using that. First one is square root of 48 is there. You can write this as 16 into 3. 16 3s are 48. What is square root of 16? 4 into root 3. Next, square root of 78 is there. What is? How do you go for writing 78? Will you go for taking 24 or then 36? 36, 36. It is equal to 72. But here 72 I have given. Correct. So you can write 36 2s are. 36 2s are 72. Square root of 36? 6 into root 2. What about 27? Yes. Express this in simplest form. How do you go for writing? It can be written as 9 3s are. Right? What is square root of 9? It is 3 into root 3 as it is. Should write root properly. Then square root of 18 is there. Even square root of 18 can be written as 9 2s are. Square root of 9, it is 3. Square root of 2 as it is. So all are expressed in simplest form. Now you tell that whether all are like sets? No. But here group of sets are like. See that here root 3, here root 3. These two, one group. Root 2, root 2. That is also one group. Now it will be easier to simplify. I go for taking this. Square root of 48. What is square root of 48? 4 root 3 minus. What is square root of 72? It is 6 root 2 minus. Square root of 27. it is 3 root 3 and one more plus 2 into, what is square root of 18? It is 3 root 2. Clear? I hope that you have understood it. Now, I go for grouping them. Here root 3 is there, here root 3 is there. Let us go for taking these two together. It is 4 root 3 minus 3 root 3. Here root 2 and here also root 2. See that? Minus 6 root 2 plus, here you can multiply. 2 3s are 6 root 2. Now plus 6 root 2 minus 6 root 2 get cancelled. It's equal to, now these two are like 4 root 3 minus 3 root 3. Root 3 is common. Then 4 minus 3. What is 4 minus 3? 1. So 1 root 3. This is the value. Clear? Let's come to fourth one. Here, they are also interesting one. Simple. Square root of 5 can be written as it is square root of 20. Can we write it in simplest form? Of course, I go for writing here directly because as they are simple numbers. 20 can be written as 4 into 5. Then root 45. 45 can be written as 9 5s. Clear? Is equal to root 5 as it is. What is square root of 4? 2. Then into root 5 plus square root of 9 3 into root 5. This is equal to, see, 1 root 5, 2 root 5 plus 3 root 5. You can go for adding 1 plus 2, 3, 3 plus 3, 6 root 5 because root 5 is common. This is the value. And one more, it is sixth one, root 50, 98, then 162 is there. Just by observing only, you can go for judging. 50, 25 twos are right. 98, 49 twos are. 162, 81 twos are. Again, no need to go for these many steps. You can go for simplifying it directly. Here I'll write. Square root of 50 can be written as 25 twos are. Square root of 98 to be written as 49 twos are. Square root of 162 can be written as 81 twos are, which is equal to, what is square root of 25? It is 5 into root 2. Square root of 49, 7 root 2. Square root of 81, 9 root 2. It's equal to, see that root 2 is common. So remaining 5 minus 7 plus 9 into root 2. Then what is 5 minus 7? Minus 2. Minus 2 plus 9? 7. Right? Or else 9 plus 5, 14. 14 minus 7? 7. 7 root 2. Understood? See, all these are very important because in your textbooks they are given few problems only. I think you find it difficult to be perfect in solving the problem. Hence, I have taken additional problems from your reference books as well. So you have to practice all these. Now you pause the video and copy from there to here. Yes, copy this. Yes, we have one more problem with respect to addition and subtraction of irrational numbers. Nothing but surds. Okay. This is sixth one. 4th root of 81 minus 8 into cube root of 216 plus 15 into 5th root of 32. Here square root of 225. See that when you observe these numbers, 81 with respect to 4, 216 with respect to 3, 32 with respect to the order 5, then 225 with respect to the order 2. What do you think? All are perfect numbers, right? Now, you can go for writing them directly as square root of 81. See that? Here, for the sake of information only, I am writing 81. 3 into 3 into 3 into 3. 3 3s are 9. 9 3s are 27. 27 3s are 81. So we can write 81 as 3 raised to the power 4. Then 216. Observe. 16 is there. So 6 into 6 into 6. I have already told you. You must be thorough about the cubes of the numbers from 1 to 10 and squares of the numbers from 1 to 25. Then our judgment will be correct. So, and also we find it easier. 6 6 are 36, 36 6 are 216. Now it is 6 cube. What about 32? Observe. 32, 2 into 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Can be written as 2 raised to the power 5. What about 225? We know that it is a perfect square. It is 15 into 15. 15 into 15. 15 square. Clear? Now I am going to write it. It is equal to, I will write from here, 4th root of 81, it is 3 raised to the power 4. 8 into cube root of 216, it is 6 cube, plus 15 into 5th root of 32. 32 is 2 raised to the power 5, plus square root of 225 is 15 square. Clear? Okay. Now this is equal to, now see that power 4, 4th root get cancelled, 3 will remain. Power 3 and cube root get cancelled. So 8 into 6 will remain. Minus 8 into 6 will remain. Plus 15 as it is. Power 5 and 5th root get cancelled, 2 will remain. Plus square and root get cancelled, 15 will remain. Now this is equal to 3 minus, what is 8 6 are? 48 plus 15 2s are 30 plus 15. It is equal to, see that, very simple one. 3 minus 48 minus 45. 30 plus 15 plus 45. These two get cancelled, the value will be 0. Clear? So important one. You might have observed the first 5 problems, just I had focused only on root numbers, square root numbers. But here I have taken cube root, 4th root, 5th root as well as square root. But in your chapter, they have focused on square root of numbers. Next, addition, subtraction are over. Now we will focus on multiplying these irrational numbers. And one condition is there. I told you in the beginning when I was explaining about like sets and unlike sets. Like sets can be added, subtracted, multiplied, divided. But unlike sets, they can be multiplied, they can be divided. Condition is there. What is that condition? Is if you want to multiply them, their order must be same. See that? Irrespective of the radicand, order here 2, here 2. Got it? Now look here. 6 into root 5. Here 2 into root 5 is there. I am going to multiply them. 6 into root 5 into 2 into root 5. It is equal to, when the orders are same, in this case, you just go for multiplying the coefficients. What are the coefficients? 6 and 2. Next, as I said, order is same. Here also 2, here also 2. Remaining 5 into 5. Understood? It is equal to, what is 6 2s are? 12. Then 5 into 5, 25. Square root of 25, 5. Clear? 12 5s are 60. So the value will be 60. Next, second one, observe. What is it? Can we multiply them? Yes. We can multiply because orders are same. Here I will write 2 into cube root of 4 into 3 into cube root of 16. It's equal to, as I told, first you multiply coefficients. 2 into 3 and order is in cube, then 4 into 16. It is equal to 2 3s are 6. Cube root of 16 4s are 64. Then how do you go for simplifying this? It is equal to 64. If you do not know, all of a sudden you can go for this method. Now look at 2 32s are 2, 16s are 2, 8s are 2, 4s are 2, 2s are. Here 2 cube, 2 cube. Understood? Yes. Here I will write 6 into cube root of 2 cube into 2 cube. It's equal to 6 into, what is cube root of 2 cube? Cube and root get cancelled, only 2 will remain. Cube root of 2 cube, again 2 will remain. 6 2s are 12, 12 2s are 24. Next, come to this one. Let's go for multiplying this. It is 3 into cube root of 32 into 3 into cube root of 4. This is equal to, multiply the coefficients, 3 into 3. Then order is same. Go for multiplying the radicals. 32 into 4. What is 3 3s are? 9. Cube root of 32 4s are 128. Then again, how do you go for simplifying? Go for this method. 128, 2, 64s are 2, 3s are 2s are 2, 16s are 2, 8s are 2, 4s are 2, 2s are here. You take these three. Hence you can write 9 into cube root of 128 can be written as 2 cube into 2 cube into 2. It is equal to 9 into cube root of 2 is 2. So cube root of 2 cube is 2. Cube root of 2 cube is again 2. Cube root of just 2 should be written as it is. Here I will write the final answer. 9 2s are 18. 18 2s are 36. 36 into cube root of 2. This is about the multiplication of sets. Now we will focus on division. And division also, here also the order must be same, irrespective of the radical. First one, square root of 6 by square root of 3. Observe, what is the order? 2. Here, that is also 2. Hence, this can be written as square root of 6 by 3. You can cancel it. 1s are, 2s are. So, root 2 is the answer. Next, here let's go for solution. Here again orders are same. Let us go for dividing. Cube root 10 by cube root 2, which is equal to cube root of 10 by 2. 1s are, 5s are. So it is cube root 5. Let us go for taking one more. It is 8 into root 15 by 2 into root 3. See how interesting it is. 2 1s are, 2 4s are. I'll write 4. Then order is same. Hence you can write square root of 15 by 3. 1s are, 5s are. So 4 into root 5. Got it? So now you can, I hope that you all have understood from there to here. Please do practice as many times as possible. Then now you are going to copy from here to here. Just copy this. Okay. Dear students, with respect to division, we have one problem. Just observe it. Here 21 into square root of 384, it should be divided by 8 into square root of 96. I go for writing this as 21 root 384 by 8 into root 96. is equal to, we can write this as 21 by 8 root of, because order is same. So square root of 384 by 96. It is equal to 21 by 8. On observing this, you can come to know, see that 384 is the multiple of 96. 96 4s are 384. Or else you can go for cancelling by 2s are. You will get 48 here, 48 and here. 1s are, 9s are, 2s are. Again, like that, if you go on cancelling, you will get square root of 4, which is equal to 21 by 8 into, what is square root of 4? It is 2. 1s are, 5s are, sorry, 4s are. It is equal to 21 by 4. See, here I don't have less space, so I have less space so that I have written horizontally, but when you are copying, it should be written one below the other. See, all the 4 operations are over. Now, we have some more type which includes both multiplication and division. I have taken such problems. Observe this. Fourth one, simplify each of the following. Here, first one, root 3 into root 8 into root 39 all divided by square root of 24 into square root of 26. One interesting thing is, here all are square root only, right? Hence, we can go for writing directly like this. Square root of, orders are same. Go for writing all the radicands. 3 into 8 into 39 whole divided by 24 into 26. 8 ones are 8 3s are. 3 ones are 3 ones are. 13 2s are 13 3s are. It is equal to square root of 3 by 2. This is the answer. Next, let's go for this. It is, here also we have root numbers. Square order is same. You can go for simplifying like this. Square root of 75 into 60 into 63 whole divided by 40 into 200, right? Now see that here 0, 0, it cancel. Now 2, 2s are 2, 3s are. It is equal to square root of 75 into 3 into 63 whole divided by 2 into 200. Observe, 75 and 200, they are the multiples of 25. 25 4s are, 25 3s are. Now this is equal to square root of 3 into 3, 3 square into 63 as it is, whole divided by, alright, 2 into 4, no need to go for multiplying. The reason is 4 is a perfect square. It is equal to, what is 3 square? It is, root 3 square is 3, root 4 is 2, square root of 63 by 2. Is there any other chances? Yes, there is chance. You can, here I am continuing, it is equal to 3 by 2 into square root of 63 is there. 63 is the multiple of 9 or 7. 7 9s are. So here I write 7 9s are by 2. It is equal to 3 by 2. What is square root of 9? It is 3. Then square root of 7 by 2. Now 3 3s are 9 by 2 into square root of 7 by 2. Clear? Yes. One more problem. Here, this is equal to, here also all are square root numbers. Again I go for following the same method. Here, sorry. And one more thing you can notice that here is coefficient, 2 is there. And here 3 is there. Here 5 is there. You can go for writing them separately. I'll write like this. It is 2 into 5 by, in the denominator 3, and remaining all are root numbers. Square root of 7 into 8 into 3 whole divided by 3 into 15 into 42. It's equal to, see, 3 get cancelled. 7 ones are 7, 6 are 42, 2 3s are 2, 4s are. It is equal to 2 into 5 by 3, square root of 4 will remain, divided by 15, 3s are 45. And this is equal to 2 5s are 10 by 3, root 4 divided by 45 can be written as 9 5s are. Right? It is equal to 10 by 3, square root of 4 is 2 by square root of 9 is 3 and root 5 as it is. Clear? It is equal to, now 10 2s are 20 by multiply 3 3s are 9 root 5. If you want to simplify again, you can go for like taking like this, root 5 by root 5. It will not affect the statement. The reason is root 5, I am cancelling root 5, 1 into this number, same number. It is equal to, see that, 20 root 5 divided by 9 into, what is root 5 into root 5? Root 5 into root 5 is root 5 whole square. Square and root get cancelled. 5 to 5. 5 ones are 4s are. It is equal to 4 by 9 root 5. Understood? Please do practice these problems. Now you have to pause the video and copy from here to here. Copy. Yes. Now we have completed all the types of problems with respect to operations on real numbers. Now we are moving to another very important concept. Let me go for giving you that information. Observe here 3 root 7 is there. What type of number it is? Rational or irrational? Or it is a real number, but I want whether it is rational or irrational. Yes, it is irrational. Can we convert this irrational number into rational? Yes or no? Yes, it can be converted. How? By multiplying another suitable number. Here 3 root 7 is there. I am going to multiply root 7 only. Then what it becomes? It is 3 into root 7 into root 7. Root 7 whole square. Square and root get cancelled. And this is 3 into 7. It is equal to 21. See, the 21 is a rational number. Clear? Is rational. This is irrational. So irrational is converted into rational. So this method of converting an irrational number into rational number. How? By multiplying another suitable irrational number. And that process is known as rationalization. What it is? Rationalization. Now let me write that. Rationalization. See that. Definition is very important. Here we are converting Q dash to Q. Got it? Let me write the definition of it. This is the definition of rationalization. Important one. Just go through that. The method of converting an irrational number into a rational number by multiplying it with another irrational is called a rationalization. Earlier, I explained that it is an irrational, it is converted into rational. To convert this into rational, what has been multiplied? See, this root 7 is multiplied. The number which is multiplied with irrational number